So in this video, we're going to go over regression and median fit lines. So we're going to go over a couple definitions, specifically linear regression, and then we're going to do an example with ice cream and math. Woohoo! So in general, a regression analysis is a process to find an equation that minimizes the distance between the graph of the equation and each point in the analysis. So specifically for a linear regression, what we're talking about is this distance between each of these points and the graph. It adds all that distance together and minimizes it to find where it needs to plot this line. So the benefit to this is that it's highly accurate, but the con is that it's not very fun to do by hand because it's a very involved calculation. And unless you're strange like me, you probably won't enjoy doing it. So another analysis is the median fit, or it's also called median line. And this one will be easier to understand with the example that we'll do. But what it does is it takes the points and it separates them into 3 sections, and it gets a median of each of those sections and then bases the line off of those 3 points. And I'll explain that better later. And the benefit to this is that it's doable by hand, but the con is that it's not as accurate as the linear regression because you're making a couple of assumptions. And recall that a median is the central number in a list of arranged values. So if we had 1, 2, 3, 5, 6, the median is 3 because it's 3 from the right and 3 from the left. So residuals indicate how accurate the best fit line is for each point. Having high residuals means you have a high error. The correlation coefficient is a fancy word for how accurate the best fit line is overall. And it has values from -1 to 1, where values of -1 and 1 are perfect, and 0 means no accuracy whatsoever. It couldn't be farther from the truth. So now we finally get to ice cream. So for this example, an ice cream company keeps account of the tubs of chocolate ice cream delivered to each of their stores in a particular area. The relationship between the store size and the tubs of ice cream is shown in the table. So there are several ways we could do a linear regression. One of them is by hand, which I'm not going to do, but you could also use a graphing calculator or a lot of other methods. But for this example, I'm going to show how to do it in Excel. So first thing I'm going to do is I'm going to copy this information into Excel. So now that I have this copied in Excel, I'm going to highlight it and click on Insert, Scatter, Scatter Plot. Then labeling this real quick. Then I'll move it to its own sheet. Okay, so we have our points plotted, and it looks like it has a positive correlation, but they also look fairly spread out, so it's likely not a very accurate graph. But the way we display the line is you click on the dataset and right-click, Add Trend Line, and you have a lot of options over here. So you can even choose different types of regressions, but we're obviously just going to stick with linear, and we want to display the equation on the graph and the r² value. And our r² is our correlation coefficient. So if we're looking at these, we can see that our equation is here, so it puts it in the point slope form. And it also gives us a correlation coefficient of 0.7231. So it's fairly accurate, but it's not quite close to 1. So this one would definitely be something that they need more data to get a better correlation for. And the reason for that is because you have these points that are really far away from the graph. Now, if we were to play around with this a little bit more and say, let's say that this one was an oddball and they only had 100 tubs of ice cream. We can go back here and it automatically changes what our graph is. And you can see now that it changed our equation and our correlation constant is really, really bad. And that's because we changed that one to be way down here. And that's how you do a linear regression with Excel. Now going back to our slides, example 2 is doing a median fit analysis for the same data so that we can kind of compare how they match up. So when we're doing a median fit analysis, we want to separate our data into 3 sections of roughly equal size, and you always want the first section to be equal to the last section. So to do that, we're going to see that we have 5 points, and we want 3 sections. Now 5 divided by 3 is 1.6 with a repeating. So we're going to round that up to 2, and that tells us that we have 2 here and 2 here. And then the remaining is just 1. So this may seem like a little silly example, but this is the process you would do if you had, let's say, 100 points. You would do 100 divided by 3. Whatever you get from that, you round up, and that tells you how many are in the first and last sections. So we're going to separate these into 3 sets, set 1, set 2, and set 3. And for each set, we want the x values, the y values, the x median of that set, and the y median of that set. So for the first set, we have 2, 1, 0, 0, 2, 2, 2, 5, and the y values of 1, 1, 0, 1, 0, 2. Now the median of the x values, since there's only 2 values here, you would average them. If there was a third value, let's say we had 1, 4, and 5 as the values, it would be the middle term. And if we had 6 on top of that, we would average 4 and 5 and you get 4.5. So the average of these two numbers is 2162. And doing the same for the y values, the average of 110 and 102 is 106. And then you would do this exact same process for all 3 data sets, which I'll speed through. So now that we have that, we want to find the slope between the medians of our first set and the medians of our last set. So I'm going to erase this to give us some room. And we're going to use the formula m is equal to y3 minus y1 over x3 minus x1. Substituting in, we get 288.5 minus 106 over 4078 minus 2162. And that gives us that our slope is equal to 0.0952. Now that we have our slope, the last thing we need is our y-intercept. And we're going to find that by using the formula, the sum of our y-medians minus the slope times the sum of our x-medians, all divided by 3. So finding the sums of each of these, we get 9375 and 609.5. Now to save space, I'll erase this and move the formula up here. And when we substitute into this formula, we'll get 609.5 minus our slope, which was 0.0952 times the sum of our x's, which was 9375. All of that divided by 3, and our final answer is negative 94. Repeating 3. So we'll just leave it as 3. Now if we were to put all this back together in our slope-intercept formula, what we would get would be y is equal to mx plus b. And we know that m was 0.0952. X plus b, which we found was negative, so this is actually minus 94.3. And that is finally our answer. Now recall that the linear regression, we got the formula y is equal to 0.0776x minus 41.4. So these two are definitely not equal, and that's because this formula, using the median fit analysis, made a couple more assumptions that made it easier to calc, so it was less accurate. So there you go.